Welcome to Trig Identities Quiz Review Part 2. In Part 1, we focused on these relationships, where given any one of the 6 trig functions and a quadrant, we were able to find any of the other trig functions. If you haven't seen Part 1, you can either click the link that appears in the upper right-hand corner, or find the link in the description. For Part 2, we will simplify a variety of trig expressions. For many problems, we will use variations of the Pythagorean identity. So if you have not memorized these yet, pause the video and memorize these right now. In Part 1, we defined all of the trig functions in terms of x, y, and r. But in Part 2, let's write all of the trig functions in terms of sine and cosine. For example, tangent theta is sine theta over cosine theta. That means cotangent theta is cosine theta over sine theta. Secant theta is the reciprocal of cosine, in other words, 1 over cosine. However, if secant is the reciprocal of cosine, that means that cosine is also the reciprocal of secant, so cosine can always be rewritten as 1 over secant. Similarly, cosecant is the reciprocal of sine, which means that sine is also the reciprocal of cosecant. Our number one strategy for simplifying trig expressions is to rewrite everything in terms of sine and cosine. So instead of cotangent theta, we could write cosine theta over sine theta. And instead of secant, we can write 1 over cosine. But then we notice that we have cosine in the numerator and the denominator. So these will cancel each other out, which gives us 1 over sine theta. But 1 over sine theta is cosecant theta. So this is the simplified answer for number 1. For number 2, we already have cosine beta, so let's leave that alone. But we can rewrite tangent in terms of sine and cosine by writing sine beta over cosine beta. And then we notice that we have a cosine in the numerator and a cosine in the denominator. These cancel each other out, leaving sine beta. Pretty easy. There is more than one way to solve problem number 3. But my first instinct is to distribute sine phi. At first we have this, but let's rewrite cosecant in terms of sine or cosine. Of course, cosecant is simply 1 over sine. Didn't feel like rewriting the whole line just for that, so poof, I changed it. But now we notice that we have a sine in the numerator and sine in the denominator, so these cancel each other out. That leaves 1 minus sine squared, which is one of our Pythagorean identities. See, 1 minus sine squared is cosine squared. And that's the simplified answer for number 3. Number 4, we just mentioned that 1 minus sine squared is cosine squared. So that means we can rewrite this as secant squared times cosine squared. But secant is the reciprocal of cosine, so in fact, instead of writing secant squared over again, I'm just going to replace it with 1 over cosine squared. But then I see that we have cosine in the numerator and cosine in the denominator. These cancel each other out, and we get the very simple expression of 1. I'm going to show you number 5 using 2 methods. First of all, there's a shortcut that I love to use. If you move a trig function from the denominator to the numerator, it changes to its reciprocal. So I'm going to leave the cotangent x alone, but I can move cosecant x up to the numerator if I turn it into the reciprocal, which is sine x. Then we can rewrite cotangent as cosine over sine. But then we notice we have a sine in the numerator and in the denominator. These cancel out, leaving behind simply cosine x. Kabam! That's the answer. So I'm going to do it again now without the shortcut. Without the shortcut, we would simply rewrite both expressions in terms of sine and cosine. So for cotangent, we will write cosine over sine. And then that's all over cosecant, which is 1 over sine. When you divide by a fraction, you multiply by the reciprocal. So on the next step, I will have cosine x over sine x times sine x over 1. I'm multiplying by the reciprocal. And then the rest is the same, because the sine x cancels out, and we are left with only the cosine. By the way, when you're simplifying like this, you are doing sort of a little proof. Every step that you do has to be equivalent to the previous step, which in turn will be equivalent to the original problem. So don't put little side notes. For example, very often I will see a student understanding that we need to multiply by the reciprocal, but instead of showing that as a separate step, they will put a little sine x over 1 right here, and then they want to cancel these out and then maybe skip straight from here down to here. That's no good. On number 6, again, when you move something from the denominator up to the numerator, you are actually taking the reciprocal of it, and the reciprocal of secant is cosine. So this expression is the same as cosecant theta cosine theta. That's the shortcut. Then cosecant theta is 1 over sine theta, so now we have this. But of course, if we put these together, it's just cosine theta over sine theta, which is cotangent theta. If you are not comfortable with bringing up the secant and turning it into a cosine, you can rewrite cosecant as 1 over sine and rewrite secant as 1 over cosine. Then, when you divide by a fraction, you multiply by the reciprocal. When you multiply these together, you get cosine theta over sine theta, which again is cotangent theta. In number 7, both the numerator and the denominator are Pythagorean identities that we need to memorize. So for example, 1 minus sine squared, that's cosine. Well, cosine squared. And what about cosecant squared minus 1? That's right here. That is cotangent squared. So far I have this. I'm going to use my shortcut again. If I move cotangent squared out of the denominator, I'm really taking the reciprocal of it. So I will have cosine squared. I'm just bringing down that same numerator. But cotangent squared will become tangent squared once I move it up. When we rewrite tangent squared as sine squared over cosine squared, we notice that we have a cosine squared in the numerator and a cosine squared in the denominator. So these cancel each other out, leaving behind sine squared x. So that's the simplified answer. On number 8, tangent squared plus 1 is one of our Pythagorean identities. Tangent squared plus 1 is secant squared. But the reciprocal of secant is cosine. So that's it for number 8. For number 9, I'm going to start by moving tangent out of the denominator and turning it into its reciprocal cotangent. So now we have secant alpha times sine alpha times cotangent alpha. Let's rewrite each of these in terms of sine and cosine. So now we have this. But notice that we have sine in the numerator and sine in the denominator. These cancel each other out. We also have cosine in the numerator and cosine in the denominator. These cancel each other out. That leaves just 1. So that's the simplified answer for number 9. For number 10, I'm going to bring the secant squared theta out of the denominator and turn it into its reciprocal, cosine squared theta. So now we have this. Rewriting tangent in terms of sine and cosine, that's sine squared theta over cosine squared theta times cosine squared theta. But then we notice that we have cosine squared theta in the denominator and in the numerator. So these cancel each other out, leaving behind sine squared theta. So that is the simplified answer.